Hello and welcome to Ramble with me. I have exactly 11 minutes to kill, so let's hope that this question does not kill me instead. We are looking at IEB May 2024's paper 2, and today the video is focusing on question 10b. Right, for what value or values of theta in the interval 0 to 360 is cos of 9 theta minus 2 cos 4 theta times cos 5 theta defined? Okay, defined is a tricky word. Right, so I in my head, undefined things are, operations like dividing by 0. That is an undefined operation, and we call that result undefined. I think is the more mathy word is indeterminate. Anyway, I don't know, but that's what I think of when I see defined. But obviously we're not dealing with a problem of division here. There's no division going on. It's a square root, so that hints to me that what they are actually asking is for which values will this square root give us non-real answers. Well, real answers, because we want to know when it's defined, inverted commas. So for what values of theta will we get a real answer, a real number, a real numeric value, not a non-real numeric value. And we know from things like working with discriminants and whatever that the square root of a negative number is non-real, or in this case we're going to say is undefined, but it's not really undefined. It is defined. It's just defined by what we call complex numbers. Right. So that is what is going to give us undefined values in air quotes. Okay. So in other words, we are looking, we're trying to solve the following inequality. For what, that theta is not convincing. For what values of theta will this expression be smaller than 0, right? If it's equal to 0, that's fine, because the square root of 0 is 0. If it's a positive number, obviously that's also fine, because the square root of a positive number will be some real number. So really all we want to know is which values of theta make this expression negative. Now, the moment I see an inequality, my mind tries to think of, well, can I sketch a graph of this for this expression and see when the graph is going to be, when it's going to lie under the x-axis, right? Because then we know that the function is outputting negative values there. But this is unlike any trig function that we studied, right? We know how to sketch this, but we don't really know how to sketch that, and let alone how to sketch all of that. So maybe I'll hold off on that idea. What did immediately strike me though is that 4 theta plus 5 theta is 9 theta. So that makes me feel like maybe I can rewrite this in terms of 4 theta and 5 theta using our compound angle identities here. And the next thought that comes to mind is, okay, well, so obviously the question then is, oh no, there's only one option. Sorry, I was going to say which one should I use, but I forgot that it's only the double angle identity of cos that has 3 options that you can use. But just to do a normal compound angle situation, the identity is very straightforward. Cos of a plus b is equal to cos a cos b minus sine a sine b. And I think I've mentioned in other videos before, I am definitely a fan of memorizing as many identities as possible, as many formulas as possible. It's just less time spent flipping back and forth in your exam. It's also good for recognizing patterns, right? So to kind of have this dictionary of rules that you can almost subconsciously compare a question to even before you started getting into the things, and I find that has helped me. Anyway, so this is our, guys, what's going on? What's happening? What's going on? 6 minutes left. Let's see. Okay, so then I'm going to write cos of 9 theta as 4 theta plus 5 theta. Right, and then that'll be 2 cos 4 theta cos 50. Okay, I would become here. This is 50. Gosh. Okay, so then that's gonna be cos 4 theta cos 5 theta minus sine 4 theta sine 5 theta minus 2 cos 4 theta. Yo, this thing's not gonna fit. Wow, 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 wow. Okay, I'm just gonna put that over there. So that's this. Okay, right. And we do have some like terms. Let me use a different color before we think there's a weird thing happening between the two yellow highlighted things. So these are our two like terms, cos 4 theta, cos 5 theta. So if I minus them, what I end up with is minus cos 4 theta cos 5 theta minus sine 4 theta sine 5 theta. Okay, and this is now looking like, again, this identity, right? Cos A cos B, and then sine A sine B, but oh yeah, but but the only difference is that I would have expected, oh okay, I see what's gonna happen. So the thing that was confusing me is that, okay, this one has a minus in front of it, right, which is not ideal for this identity. But then I remembered the difference identity. Let me stop trying to write cute when I know my hand be a problem. Cos of A minus B, I don't actually remember what that identity says, so I'm just gonna quickly work it out because I also don't have my formula sheet nearby. So that will be cos A and cos minus B, and then minus sine A and sine of minus B. So that ends up being minus cos A cos B using our reduction what's. Oh no, cos is positive in the fourth quadrant if the angle is acute. Okay, so that is actually cos A. Hey, what? We've enabled the ability to also switch back to your last used tool. Oh, that's nice. Thank you. That's actually very handy. Thank you. I love to see it when people are constantly improving their products. And sine of negative b will be minus sine b, and because this term already has a negative situation going on, the two negatives are going to turn into a plus. Okay, so this is what is going to come in handy for us shortly. So if I times through by minus 1, 2 minutes left, the pressure of it all, then I'm gonna get this on the one side, and then my inequality sign is going to switch around because you've times through with a negative 1, right? So that's what's happened there. And then now we can see that this looks like this, right? Cos A cos B plus sine A sine B. So that means we can write this as cos of 4 theta minus 5 theta, right, which is just the same as cos of negative theta, right? And cos of negative theta is just the same as cos theta. We can just look at what's happening, what's the behavior of cos theta to understand the behavior of cos negative theta, right? Because another way to think about it is so the graph of cos theta looks something like this, right? And the graph of cos of negative theta, so the coefficient of theta is in charge of either stretching so changing the period of the graph, so it could end up being a very squished graph or a very stretched graph. But here the coefficient is -1, so the negative is in charge of reflecting in the y-axis, I believe. Yes, because if I just think of y is equal to x, it looks like that, and y is equal to minus x, it looks like that. These are horrible, sketchy. So the one piece came here and the other piece came here. So this piece came here and this piece came here. I don't know if I'm thinking about this the right way, actually. I feel like reflecting in the x-axis would give me the same result. So actually that reasoning was a bit of a zero. Let me think about it in terms of something a bit more complicated. So let's say y is equal to x squared will look like that. Y is equal to minus x squared. So this is just the same as me timesing the equation by -1, right? So then we know that that looks like this. And then y is equal to, now I'm negating specifically the input. I'm not just timesing the whole equation by -1. So that is the same as x squared, which looks like this. So this confirms to me that, okay, if I negate the input, same as I'm doing here, the effect on the original function, I'm treating this as my original function, is going to be a reflection in the y-axis, not a reflection in the x-axis. Okay, righty doos. Let me move this away. Right, so now, after that very long-winded exploration, I can come back with confidence and say that cos of minus theta is then a reflection of this graph in the y-axis. And so we can see why it's identical, right? Because this piece is going to come here, and this piece is going to come here, and this piece is going to come here, and that piece is going to come here. So it ends up looking like the exact same graph. Okay. Anyway, so all this to say, you know, this move is perfectly valid. And, you know, you didn't even have to do it this way. You can just reason about your sketch of cos of minus theta and say, okay, for which values is this function producing positive numbers? And that's going to be, and we're specifically looking in the in the interval 0 to 360, so that's even easier. That means we don't even care about this little piece over here. Right, this is immaterial to us. Oh, okay, there's a downside to this eraser thing. Okay, so the part of the graph that we are interested in is this one and this one, right? So what are the x-intercepts? 90 degrees and 270 degrees. So if we choose any angle, so if we choose a theta that is between 90 and, actually, I always like to decide on my brackets last. Ooh, you can see I'm panicking. Okay, so I first write down the boundaries. So it has to be a number between 0 and 90, and then there's a union situation, because the other piece of the graph that also satisfies this condition is from 270 until 360. So 270 until 360, right? Then after I've written my intervals, I like to think about, okay, am I including theta from theta to 90? Theta from 0 to 90 is what I mean. Right, so am I including 0? So when theta is 0, we have a positive number for cos of negative theta, so I can square root that result, that's fine. What about when theta is 90? We are looking for places where, hey, actually I've been wrong this whole time. Oh, no, I am right, sorry. I was wondering why we didn't do or equal to 0, but if we look at the original inequality, we said we're looking for thetas that are going to make this expression strictly smaller than 0. If it's equal to 0, that's fine. But if it's smaller than 0, that is not fine. Okay, so that's why there's no or equal to. So that means that 90 is not allowed because cos of minus theta, cos of minus 90 is going to be exactly 0. And that does not satisfy this inequality that we've eventually arrived at. 0 is not greater than 0. So the 90 has got to be excluded. And similarly, the 270 has to exclude it as well. It has to be excluded as well because cos of negative 270 or cos of 270 is also 0. So that is not included. 360 is fine because cos of negative 360 or cos of 360 is 1. And we can, no, I don't care about the square root. We're not talking about the square root here. We're looking strictly at this. Okay, because this is the simplified inequality and this is what we need to compare against. So, yeah, because cos of 360 is greater than 0, then we can include 360 in the solution. Right, let's see what the memo thinks. Yeah, I'm always nervous when I work too quickly because there's the big risk of making silly mistakes. But let's see if the memo is happy with me. So yeah, the memo and I, we are in agreement. We are in agreement. Okay, so they say, oh my goodness, what have I done? They have it the other way around. Ooh, let's quickly see where I went wrong. So they have okay, so we were in agreement until we were not. So they ended up with cos theta must be smaller than or equal to 0. I ended up with the opposite. So where did I go wrong? I have a feeling that maybe somewhere here I messed things up. No, so cos of theta must... So they have there... Okay, so they have... Let's see. So we want this expression to be smaller than 0, which means we want this expression to be positive. That makes sense to me. So we want cos of 4 theta minus 5 theta to be positive, but that's where we disagree, and I kind of see what they're saying, so I'm feeling like, I am lying. Ooh, these quick questions that end up not being very quick. Oh my gosh. Okay, let me think about this again. So this is cos of 4 theta plus 5 theta. That's that. Right. Then we rewrote it as cos 4 theta cos 5 theta minus sine 4 theta sine 5 theta, which is what they've also written. Cool. And then that simplifies to minus cos 4 theta cos 5 theta minus sine 4 theta sine 5 theta. Yes. And then the step that I didn't write out is minus cos 4 theta. So if I factor out that minus 1, then this is what I'm left with inside my brackets. And we're saying that has to be negative. And oh, ish. Okay, so my inequality is wrong. So the only way that this is going to be true is if, so the only way that this is going to be, so pretty much the only way this expression is going to be negative is if this part is positive, right? If this part is positive and then we times it with a negative, then we're going to end up with a negative number, right? So the inequality that I solved is the values of theta for which the expression won't be defined, because I said if this is negative, then this won't, it will be undefined. And the question asked for, when is it defined? Okay, so what we ended up highlighting here, okay, is the places where the original expression will be undefined, right? And the part that we actually want is this part over here, because if I put any value between these two, so from 90 included up until and including 270, then this expression will be fine. And this is where double checking also helps, because if I had just tested my answer and said, okay, let's just test the number 10, an angle with size 10, so that would be cos 90 minus 2 cos 40 cos 50, and we would get a non-real number. You see the little I over there, that tells me that this is a complex number. Whereas if I chose a number between 90 and 270, so let's say 150, not 150, why am I just putting it by odd numbers? Okay, so it's going to be 159 times 150, and then 4 times 150, and 5 times 150. Whoa. 5 times 150, then I get a real number. Oh, guys. Okay, so I hope that the solution makes sense now. So the easier way to solve this would have been to set up an inequality that answers the question directly, not the opposite, right? So instead of trying to solve this inequality and then remembering to think about the results in the inverse, you would rather just set up an inequality that says that this expression will be defined, in inverted commas, if hash is greater than or equal to 0, and then that just becomes the inequality that you solve. So this would then become, we're solving for when this expression, when will this expression be greater than or equal to 0? So then that's going to change everything. Right, so now the equation that the inequality we're solving is, when is this thing going to be greater than or equal to 0? So the only way that can happen is if this part over here is negative, because then it will times this negative, and then will, or if it's equal to 0, that will also work. So that's the sense of it all. So that's why I've got all my signs mixed up. So this will be smaller than or equal to 0, and all the reasoning over here still holds. Right, so now over here, instead of caring about these parts, we're looking for the parts where the function, this thing of expecting my eraser to still be on. I might turn it off. So this is the part of the function we're interested in, the part where this guy is below the x-axis, or we have values equal to 0. So 90 and 270 are fine because we get 0 out of the function, and then all of these values are also fine because the value of this function over here is negative, and when I times it with the original negative that we factored out, that we got rid of over here, then I am going to end up with a positive number that I can then square root. Okay, as always, it's always a pleasure going on these adventures with you. I hope to catch you another time.